Good morning, everyone. My name is Josh Wheeler. I work for the Gallatin Fire Department. Worked for Gallatin Fire Department for 2.5 years. Before we get started, can everybody see the screen okay?
Sir.
Can everybody see the marker whiteboard okay?
Yes, sir.
The visual aids I have for you guys is this projector screen, the whiteboard, and then also the tools we have in front of you. Is the temperature in here okay for everyone?
That's good.
Good. Fire exits are right off the kitchen out this door, or down this hallway, out the door into the bay, into the parking lot. The restrooms are through this door, straight back to the locker room. My contact information is over here on the board, my cell phone number and email address. If after this class you guys have any questions, don't hesitate to reach out to me. The information in this PowerPoint is from the Fundamentals of Fire Skills, 2nd edition, Jones and Bartlett. So what we're talking about today is forcible entry. I know all you guys in this room are well versed in, so this will be more of a refresher. But the objectives of this class, we're going to cover types of doors, types of door frames, PPE used, and then at the end of the class, you guys will do a forcing an inward opening door skill. There will be a short written exam, and then a skills evaluation. So let's get into it. Types of doors. Doors are categorized by how they open. Inward opening, outward opening, sliding doors, revolving doors, and overhead doors. When I think of inward opening doors, I think of a residential setting. They can be made of wood, metal, or glass inside a wood or metal frame. Outward opening doors, I tend to think commercial setting, at least the first door you come to, the exit door. Once you make entry, the interior doors will probably go to inward opening. The reason a lot of the commercial doors are outward opening is outward doors are easier to exit. Studies and statistics show in case of emergencies or fires, outward swinging doors are easier to get out of. Sliding doors, they are made of tempered glass. They can be automatic or manual. A lot of times we'll see manual sliding doors in residential homes leading out to porches or patios. And then also in hotels that lead out to balconies. So if you're making the fire floor that's above grade and you start off on a balcony, you may encounter these. The locks on these are fairly weak, but for that reason, a lot of times there will be a security rod placed in the track between the door and the frame. So if you encounter one of these doors, be mindful to look for that security rod. If it's not there, you can defeat the lock fairly easily with a prying tool. If it is there, you'll either have to remove the door from the track or, worst case scenario, break the glass. Just keep in mind, if you break the glass, you lose the ability to control that flow path to the fire. Revolving doors. I don't believe what we have in here in Gallatin. Really, the automatic sliding doors kind of took its place, but you still may run into these somewhere. You'll find them in upscale businesses or buildings. But really, you want to avoid these doors if possible. When you can defeat the latch, last case scenario, break the glass. It's just made out of 4 glass panels. But even when you make access, the size of the opening that it offers really isn't efficient for ease of access, entry, or exit. And then lastly, overhead doors. Where do you guys think we would see overhead doors? Somebody from the class.
Garages, industrial.
Absolutely, both of you guys. That's what I thought of too. I think of commercial loading docks. We have a ton of those in this city off Airport Road. And then also, every home now is built with an attached garage that's going to have a garage door. The garage doors will be made of either wood or metal. Usually it's 5 separate panels. A lot of times the middle panel will be glass for aesthetics and also to let natural light into the garage. The way we can access these doors is you can remove the panel, operate the door manually, operate the lock manually, raise the door. Just, if you do that, make sure you secure it in an upward position so it doesn't accidentally come down and injure somebody or pinch off the attack hose. Or you can take a K-12 and make a triangle cut method. I'm sure all you guys have seen that in your Firefighter 1 or Firefighter 2 practicals or skills. Says, any questions involving evolving types of doors? Fantastic. Types of doors continue. So this is getting into sizing up the door a little bit. But hinges indicate if door is inward or outward opening. Outward hinges are visible, inward hinges are not visible. So it is how it reads. When you're walking up to the door and you're sizing up the door, you're looking for the location and amount of locking mechanisms, and you're also looking for the presence or non-presence of hinges. In this picture, we can see that we see the hinges, so we know that this door swings outward. Also, I'd like to add that we can see the seam between the door and the jamb. I like that it stays together. If we can see the hinges and we can see the seam, we know that it swings outward. If we cannot see the hinges and we cannot see the seam, because on an inward swinging door, we're going to have a stop here that stops the door from swinging past the latch, then we know it's an inward swinging door. Door frames. We have two styles of wooded frame doors, stopped and rabbeted. Stopped door frames have a piece of wood that is added onto the door frame after the fact with nails or screws to keep that door from swinging past the latch. Rabbeted doors are made into the frame. They're cut or milled from the factory to have that stop built in. The reason that's important for us to know is if we come in contact with a stop door frame, we can remove that stop fairly easily with a prying tool, making access to the seam between the door and the jamb much easier. If it's rabbeted, it still doesn't change our game plan. We're still going to force the Halligan around, past the stop, around the jamb, but stock door frames are easier to force. Metal door frames are more difficult to force because they are rabbeted. They don't have that stop that's added on later with a screw or nail. It's made from the factory. It's bent or molded from the factory to have that stop. Touching on inward opening doors again, the design, again, they can be made of wood, steel, or glass. They can have an exterior frame with a stop or rabbet, and the locking mechanisms range from standard doorknob locks to deadbolt locks or sliding latches, or all three depending on the area that you're operating in. So just as a review, we have 5 types of doors. They're categorized by how they open. We have 2 styles of wooded frame doors, stopped or rabbeted. Can somebody tell me the difference between stopped or rabbeted door frames?
Seems like the stop is like an add-on, where the rabbeted is kind of cut into the wood from the get-go.
Absolutely. And then also somebody else tell me which door, if possible, should we avoid due to the size of the opening that it makes once you access it?
Revolving doors?
Absolutely, revolving. It's really not worth the bang for buck for those doors. So before we start the next PowerPoint, we're going to go over the tools we're going to use today. The first one being the flathead axe. I know all you guys in here have seen one, but just for a quick review, it's basically 2 parts. It has a handle, either wood or fiberglass, and then a metal axe head. It has a cutting or chopping side and a flat or striking side. For this PowerPoint, for this class, for the skill we're going to do out here in a minute, we're really focusing on the striking side of the tool. But I'll pass that around and let you guys go look at it. While you guys are looking at it, we'll go over the parts of the Halligan. On top here we have a 6-inch by 2-inch adze, a 6-inch pike, and then at the other end we have 6-inch forks. The overall length of this tool is 30 inches from the tips of the fork to the top of the adze. And in 1948, Hugh Halligan developed this. The originals took him about 18 hours to make. Since then, has been the tool of choice for fire departments with forcible entry. The reason being is its mechanical advantage that it offers, or its ability to multiply force. So if this tool is used correctly, if we place the adze in between the door stop and door on an inward swinging door and pry up or down, we are getting 15-to-1 mechanical advantage out of these adds. We get that by applying force over the 30-inch bar across a 2-inch span. 30 divided by 2 is 15. That gives us our 15-to-1. We can leave that tool in the same position and pry left or right on the forks, and we get a 5-to-1 mechanical advantage. That is because we're still applying force over the 30-inch bar, but now across a 6-inch space. 30 divided by 6, 5.1 mechanical advantage. And then also, if we use the forks, in the second PowerPoint, that our skill, the steps is to use the forks to force the door. It's a roughly a 5-to-1 mechanical advantage. The reason being, the forks is 6 inches, but this V cut out in the center is called the crotch. It's roughly 5 inches long. So out here in the bay today, when you drive this Halligan with the concave side of the forks wrapping the door jamb to the crotch, you've drove it 5 inches up the bar. So now the length of our leverage side of our bar is 25 inches, and we're going to be pushing across a 5-inch span. 25 divided by 5 is 5 point. Still roughly a 5-to-1 mechanical advantage. Any questions over the tools? Awesome. Give me just a second to pull up the other PowerPoint. So we're going to get into this PowerPoint is covering the skill that we're going to go out and perform in just a minute. The objectives of the PowerPoint, we'll talk about, one, the steps for forcing an inward opening door, the PPE required, the command, and the commands used between the two firemen. Touching on inward opening doors one more time, just because that's the skill we're about to go do. They're made of wood, steel, or glass. They're found in most structures. Again, they're probably the most common door type you'll run into. They'll have a stop or rabbet that keeps the door from opening past the latch. Again, if we want to run into the stopped door styles, just frame styles, to aid in forcing the door, and may have lock knobs, deadbolts, or sliding latches. So, skill drill 11.1, forcing entry into an inward opening door. So step 1, size up the door, inspect the door for the location and number of locks and mechanisms. So this fireman has gotten off the truck. His assignment is to gain access through this door. As he's walking up, he's sizing up the door by looking for, one, the amount and location of locks, the presence or non-presence of hinges, and then also any hazards that he may come in contact with. So a big hazard that I think of is maybe fire impingement on the roof of above him, so maybe possible for structural collapse. Maybe the door's on fire, so that would be a hazard, wouldn't it? Luckily, this fireman has got all of his gear on; he's prepared for it, but it's still stuff you want to be mindful for. So you can see in the picture, the only visible lock that he sees is the actual doorknob latch. We don't see a deadbolt keyhole. What may be back here that we don't know is a sliding latch. Luckily, sliding latches are fairly weak. They're not very hard to force past. And then somebody tell me what he's doing right here.
Try before you cry.
Absolutely. This fireman is making sure the door isn't unlocked already. Even though we're firemen, we like breaking stuff, we want to force this door. Keeping the victims in mind, we are going to get to them or get water on the fire much faster by just opening the door and going in versus forcing. Step 2, he places the forward end of the Halligan tool into the door frame and inserts it near the lock. So he is taking his Halligan, the beveled side of the Halligan towards the door, and inserting it between the door and the door stop, not on the door stop itself. Oh, wrong way. Step 3. Have your partner drive the tool farther into the gap between the rabbeted jamb or stop and the door. So real quick, let's go over the commands we use between the two firemen operating the Halligan or the axe. So we use hit, which is one hit, drive, which is continual hits, stop is stop, and wedge is capture, progress made. So the first fireman, he's getting his Halligan in position. He may call for one hit, so his axe man hits the Halligan one time with the axe to see if the tool is going to do what he wants it to do. Once he feels like it's in position, he'll call for drive to get continual hits until he has driven the forks of his Halligan to the depth into the jam that he wants. He'll call for stop. That is telling the second fireman to stop swinging the axe. And then if any point the Halligan guy needs to reposition his tool, he can call for a wedge, and that tells the second fireman to capture, progress made, meaning stick the wedge, the cutting side of the axe, into the gap between the door and the door frame to hold the progress. We don't want to lose that progress that we made. A couple safety considerations. The Halligan man, whoever's the Halligan man out there today, when you call for that hit or drive, try to hold the Halligan underhanded or palm up. That keeps your elbow tucked in next to your body. If you hold it overhand, that puts your elbow out in risk of getting hit. Second, again for the Halligan, the fireman using the Halligan, after you've called for drive and he has drove the force of the Halligan to the depth you want and you call for stop, turn to that fireman and say stop and confirm that he has heard you say stop. If you're still pointing towards the door and you say stop and then you go to move this, again, you're putting yourself at risk of getting hit by the axe. Finally, the last step. Once the tool is in place, push the Halligan tool toward the door to force it open, and then secure the door to prevent it from closing behind you. But I feel like step 4 is fairly straightforward. Once the tool's in position, push the Halligan towards the door to force it open. What I do want to elaborate on is the second part. It says secure the door to prevent it from closing behind you. Does anybody see, can anybody think of a problem with that?
Introduce more fuel with fire.
Close. We don't introduce more oxygen to the fire, right?
Yeah,
We're opening that flow path and letting that fire breathe all at once. So this is situational to me. If the engine company is right behind you, or if the search company is right behind you, ready to make entry, then yes, secure the door open. That way the door doesn't close on the hose, or if the search team's in there, they won't lose their way out. But if engine and search companies are delayed and it's going to be a minute, we don't want to leave that door open. We want to close it, control that flow path. But the nice thing is, no matter if they're right behind you, if it's going to be a minute, when you force this door, you want to perform a quick toes to threshold 6-foot search inside the room looking for victims. Statistically, a lot of victims are found within 6 to 8 feet of an exit. Also, while you're in there, listen. You might hear the fire, see the fire. You get a layout of the room. Very valuable information you can pass on to the engine or search team. That shouldn't take more than 10 to 15 seconds. And then, depending on the situation, whether you need to back up and secure the door open or close it, we still want to get that 10 to 15 second search for victims, get a layout of the room. Any questions over what we just covered? Okay. A quick review as far as steps go. Step 1, we want to size up the door. Again, looking for locations of or presence or non-presence of hinges, locations and number of locks or mechanisms. Insert the force of the Halligan into between the stop and the door, near the lock. Step 3, using the commands hit, drive, stop, and wedge, have your partner drive the force of the Halligan into position between the door and the door stop. And then step 4, force the door by pushing the Halligan tool towards the door. and then securing the door either open for an engine company that's right behind you, or closing the door to control that flow path. Somebody tell me what is done when we size up the door. Again, we are looking at
how many locks, what kind of locks.
Absolutely.
If it's inward swinging or outward swinging.
Yes.
Maybe check the heat.
Absolutely.
Palm
Checking for
or
heat, that could be a
vacuum.
hazard. Fantastic. Second question. Without looking at the board, what are the commands used between the two firemen forcing the inward opening door?
Hit, drive, stop, wedge.
Absolutely. Fantastic job. I do believe that is the end of the PowerPoint. What we will do now is take a short 10-minute break, and then we'll meet in the bay. I need 2 of you guys to dress into the PPE required, which is bunker pants, boots, coat, gloves, helmet, and eye protection. And we'll perform the skill of forcing an inward opening door, and then meet back in here for the short written exam. Thank you. So we're out here in the bay. We have our forcible entry prop, inward swinging door. I have Engineer Lynn and Firefighter Kuykendall wearing the proper PPE required. Turnout coat, bunker pants, gloves, helmet, and eye protection. Their skill performing is forcing an inward swinging door. The scenario is the engine company is right behind them waiting to make entry. You guys good with that? Okay. When you're ready.
All right, so once again, we're coming up to the doorway and we're gonna size it up to see how many locking mechanisms we have to overcome. We're also gonna examine it for hinges, and since we have no hinges shown, it indicates that it's an inward swinging door. All right, ready? Nice. Hit. 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 Drive. Stop. Hit. Hit. Stop. We're going to control the door for the flow path.
Good job. You sized up the door well. You guys worked together good to get the tool set in the door. The force went well. Once you forced the door, you done a quick 6-foot search for victims, and then controlled the door for flow path until the engine company was ready. Good job. So, pause. Okay, so 2 firemen are going to switch positions. Engineer Lynn will be on the Halligan. Firefighter Kuykendall will be his axeman. The same skill, forcing an inward swinging door. The scenario is that the engine company is right behind you.
Okay.
When you're ready.
Okay. Sizing up the door, looking for locking mechanisms, looking for the presence of hinges. There's not, so I know it's an inward swinging. Good try before prime. You ready? Hit.
Hit. Hit. Hit.
Drive. Door secured open.
Good job. You sized up the door. You checked for locking mechanisms and where the presence or non-presence of hinges. Found that you knew there was an inward opening door. You guys worked together well to get to bury the Halligan where it needed to be. The force went well. You done your 6-foot search once the force was open, and then secured the door open for the engine